Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning with a new topic today and it's on surds. What are the objectives that you look forward to achieving at the end of this topic? At the end of this topic, you should be able to understand the properties of a surd. You will be able to reduce surds to its basic form. You'll be able to add, subtract, multiply, and divide surds. And you will be able to rationalize a surd. We are going to use calculators in this topic a lot, and this is the type of calculator I'll be using. So I recommend that you get one close to you. Now, let's begin with surds. We are going to consider these numbers. So we have these numbers here: square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, and square root of 49. Now we are going to take the square root of these numbers on our calculators and see something. So we begin with square root of 4. So you switch on a calculator and you press square root of 4. And the answer we are having is 2. So you write that there. Square root of 4 is giving us 2. Now, let's go to the next one. Square root of 9. So we pick square root of 9. And we are having 3. So we are going to write that one also there. So square root of 9 is giving us 3. Then, we move on to the next one, which is square root of 16. So square root of 16 is giving us 4. Square root of 16 is giving us 4. So we are going to write that one also there. Square root of 16 gave us 4. Then we move on to square root of 25. Square root of 25 is going to give us 5. So square root of 25 gave us 5. So you write that one also here. Square root of 25 is giving us 5. Then we move on to the next one, square root of 36. So square root of 36, and we are getting 6. So we pick the pen. Square root of 36 is giving us 6. Then we move on to the last one, which is square root of 49. So on our calculator, square root of 49 is giving us 7. So square root of 49 is also 7. So 7. Now you can see from here that we pick the square root of 4, we got 2. Square root of 4, we got 2. Square root of 9, we got 3. Square root of 16, we got 4. Square root of 25, we got 5. Square root of 36, we got 6. And square root of 49, we got 7. So we put square root of these numbers and we are getting whole numbers. Square root of 4, we are getting a whole number. Of 9, of 16, of 25, of 36, and of 49, we are getting a whole number. Let's consider these numbers: square root of 2, square root of 9, square root of 3, and square root of 5. Now we are going to do as we did on the calculator. We are going to do the same thing. So let's begin with the square root of 2. Square root of 2 is giving us 1.41421356. Now you can see from here that there is a difference. This time square root of 2 is not giving us a whole number, but it's giving us a whole number and a decimal part. If you watch the video on real number system, you realize that this is an example of an irrational number because there is no repeating order in the decimal parts and it continues up to infinity. Let's look at square root of 3 too. Square root of 3, and we are getting 1.7320500808. And you can see also from here that the decimals will continue up to infinity and there is no clear pattern in it. Square root of 5 will also give us something similar. That one is also giving us 2.236067977. Remember, the decimal does not end here. It's because the calculator can give only up to this number of decimal places. This continues up to infinity and there is no clear pattern here, so it's an irrational number. If you continue with other examples, that is square root of 6, square root of 7, and square root of 11, they are all going to give you something similar as to the ones we have for square root of 2, square root of 3, and square root of 5. So you can see that there is a clear difference between the square root of these numbers and the square root of these numbers. Whereas when you come here, the square root of 4, 9, 16, 25, 36, and 49 are giving us whole numbers. These ones are giving us irrational numbers. So if you want the exact value of square root of 2, you have to leave your answer in the square root form, that is square root of 2. Because if you don't, your answer is going to be an approximation. Sometimes we want the exact values for our computation, so you have to leave our answer in the square root form. So sets are numbers that are left in square root form to express their exact value. So when you come here, you can see that to express the exact value or to find the exact value of square root of 2, you have to leave it in the square root form, because if you find square root of 2 on your calculator, if you find the square root of 2 on your calculator, we are having 1.414213562. We don't know where this is going to end. So if you want the exact value of square root of 2, then you have to leave your answer as square root of 2. So numbers such as square root of 2, numbers that you have to leave them in square root form in order to find their exact values are what we call sets. When you come here, square root of 4 is not a set, because if you find the square root of 4, you are getting 2, which is the exact value. We can find that easily. So you don't have to leave your answer in square root of 4. Square root of 4 will give you a whole number, which is 2. But when you come here, square root of 2 is giving us an irrational number. So to find the exact value, you have to leave our answer just as square root of 2 is, such that you have the exact value. Such numbers are what we refer to as sets. So square root of 2 is a set, square root of 3 is a set, square root of 5 is a set, square root of 6 is a set, square root of 7 is a set, and square root of 11 is also a set. But when you come here, the square root of 36 is not a set, because square root of 36 will give us a whole number, which is 6. Thank you for watching this video. See you in the next video, where we will look at the properties of a set. Bye bye. This is the second video on sets. In the previous video, we considered what a set is. We also looked at some examples of sets. In this video, we are going to consider the properties of a set. So let's begin with the first property. The first property says that if you have square root of a number raised to the power 2 is the same as the number in question. So what are some examples? If you have square root of 2 squared is the same as 2. If you have square root of 5 squared is the same as 5. Or if you have square root of 8 squared is the same as 8. So whenever you have a term under the square root sign and the term is raised to the power 2, if you take the square root of that term, you are going to get the same number. So here square root of x squared will give us x. So if you have a term raised to the power 2 and you take square root of that term, you are going to get the term in question. So here, if you take the square root of 2 squared, you get 2. You take the square root of 5 squared, you get 5. And you take the square root of 8 squared, you get 8. Let's look at the second property. If you have square root of a term times square root of the same term is equal to the term in question. So here, square root of x times square root of x will give us x. So if you have square root of 3, you multiply that with square root of 3, you get 3. If you have square root of 7, you multiply that by square root of 7, you get 7. If you have square root of 4 and you multiply that by square root of 4, you are going to get 4. Let's look at the next property. If you have square root of a term, say x, and you multiply that with square root of a term, say y, is given by, you write a bigger square root, then the terms under the square root sign will multiply. So here x will multiply y. So when you come here, you are going to get square root of x times y, which will give you square root of xy. Let's take an example. If you have square root of 3 multiplying square root of, if you have square root of 2 multiplying square root of 3, is the same as square root of, then you multiply the terms under the square root sign. So 2 times 3. We do that 2 times 3 is 6. So this is going to give a square root of 6. Another example, if you have square root of 3 multiplying square root of 13, is going to be square root of 3 times 13. You know that if you multiply 3 by 13, you are going to get 39. So this is going to give a square root of 39. Let's look at another example. If you have square root of 5 multiplying square root of 6, it's going to give you square root of 5 times 6. We know that 5 times 6 is 30. So this is going to give us square root of 30. Another one, the fourth property. If you have square root of x divided by square root of y, is the same as square root of x over y. Now remember, you can simplify x and y further if there are common factors to cancel out. So let's pick an example. We have square root of 2 dividing square root of 3 is the same as square root of 2 over 3. Since we don't have any common factors among 2 and 3, we will leave it in this form. Now let's look at the next example. We have square root of 9 dividing square root of 3. This is the same as square root of 9 over 3. We can see from here that 3 is a factor of 9. So 3 will cancel itself 1 and cancel 9 3 times. So this is going to give us square root of 3. So the third one, square root of 14 divided by square root of 7 will give us, square root of 2 will give us square root of 14 divided by 2. So you write a bigger square root, then you divide the numbers under the square root sign. So 14 divided by 2, and this is going to give us square root of 7, since 2 will cancel itself 1 and cancel 14 7 times. Let's look at the fifth property. If you have a number, say a, multiplying another set, square root of b, is given as a root b. So an example, if you have 2 multiplying square root of 3, this is going to give us 2 square root of 3. If you have 2 multiplying square root of 2, it's going to give us 2 root 2 or 2 square root of 2. Then, if you have negative 3 multiplying square root of 7, it's going to give us negative 3 root 7. Then, if you have 5 multiplying negative square root of 11, is going to give us negative 5 square root of 11. So the negative here will multiply, the negative 1 which is in front of the negative 11 here will multiply 5 to give us negative 5 square root of 11. So you don't leave the negative sign on the square root here, so you bring it outside to the number here. It's going to give us negative 5 root 11. Let's look at the sixth property. If you have a root b multiplying a root d, it's going to give us the numbers in front of the square root sign will multiply. So a times c, then a bigger square root, you write a bigger square root. The number under the square root sign will multiply. So b times d under the square root sign. This will give us ac square root of bd. An example, if you have 2 root 3 multiplying 5 root 11, the numbers in front of the square root sign will multiply. So you are going to have 2 times 5, then square root of the numbers under the square root sign will multiply. So 3 times 11, as you can see here. 2 times 5 will give us 10. 3 times 11 will give us 33. So we have 10 root 33. If you have negative 3 root 2 multiplying 5 root 7, the numbers in front of the square root sign will multiply. So we have negative 3 times 5 in one bracket. Then square root of the numbers under the square root sign will multiply. So 2 times 7. So you're going to have negative 15 square root of 14. Since 2 times 7 will give us 14. If you have 6 square root of 8 multiplying, 6 square root of 5 multiplying 8 square root of 2, the numbers in front of the square root sign will multiply. So 6 times 8, then square root of the numbers under the square root sign. So 2 times 5 will multiply. So you have 6 times 8 will give us 48, then square root of 10, since 5 times 2 will give us 10. Let's look at the seventh property. If you have a root b multiplying square root of c is the same as a square root of b times c. Since when you come here there is no number in front of this square root sign, we assume that the number there is 1. So a will multiply 1 to give us a. Then when we come here, the numbers under the square root sign will multiply. So b will multiply c to give us bc. An example, if you have 2 root 3 multiplying square root of 5, 2 will multiply the imaginary number here, which is 1. So 2 times 1 will give us 2. Then 3 will multiply 5 under the square root sign to give us 15. So this will give us 2 root 15. Now here we have 4 root 7 times square root of 6. Actually, the square root of 6 is 1 root 6, but since it's 1, we don't write it there. So 4 will multiply that 1 to give us 4. Then the numbers under the square root sign will multiply. So 7 times 6 will multiply to give us 42. So this will give us 4 root 42. Now when you come here, we have 3 root 2 times negative root 10. So when you come here, the number in front of this here will be 1. So this is going to be negative 1 root 10. So 3 will multiply negative 1 to give us negative 3. Then the numbers under the square root sign will multiply. So 3 times 10 will multiply to give us 20. So this will give us negative 3 root 20. We look at the last property, which is the property 8. If you have a times b root c, remember this time the 10 that begins the whole thing doesn't have a square root sign. So a doesn't have a square root sign. When that happens, multiply a with b, then square root of c. So a times b root c. So you are going to get ab root c. So let's take some examples. If you have 5 times 3 root 2, it's going to give us 5 times 3, then square root of 2. 5 times 3 is 15, so root 2. If you have negative 2 times 4 root 7, you are going to have negative 2 times 4 square root of 7. Negative 2 times 4 will give us negative 8, then square root of 7. If you have 9 times negative 2 root 3, 9 will multiply negative 2, then square root of 3. 9 times negative 2 will give us negative 10, negative 18, then square root of 3. Thank you so much for watching this video on the properties of surd. See you in the next video where we are going to use the properties of surd we've learned in this video to reduce surds to its basic form. Bye bye. We are on the topic surds and this is the third video on surds. In the previous video, we considered the properties of a surd. In this video, we are going to use the properties of a surd to reduce surds to its basic form. So let's learn how this is done. Reduction of surds to its basic form. If square root of x cannot be reduced any further, it is said to be in its basic form. So whenever you have a surd and you can't reduce it any further, we say that the surd is in its basic form. Now, let's look at examples of those. We have square root of 2, square root of 3, and square root of 5. Now, how can you see whether a surd can be reduced further or not? I'm going to show you how you can use your calculator to determine that. So, let's press square root of 2 on our calculator. Now, when you press equal to, you see the calculator is giving you a square root of 2, which means that the surd is in its basic form. It can't reduce it any further. If you try square root of 3, the calculator is giving you a square root of 3. It can't reduce it any further. If you try square root of 5, the calculator is giving you a square root of 5. It means that it can't reduce it any further. Now let's pick some other examples to explain my point. Let's say that we have square root of 20, square root of 96, and square root of 24. Now let's try this on the calculator. Let's press square root of 20. Now you see the calculator is giving us 2 root 5, which means that square root of 20 can be reduced further. It can be reduced to 2 root 5. So square root of 20 is not in its basic form. If you take square root of 96, the calculator is giving us 4 root 6, which means that square root of 96 can also be reduced further. It's not in this basic form. If you take square root of 24, the calculator is giving us 2 root 6, which means that square root of 24 can also be reduced further. It's not in its basic form. So when you have the said in such a way that it can't be reduced to any further, it is said to be in its basic form. But whenever you have it in a form such as we have these ones, you have to reduce them to its basic form before further computations can be done. So in this video, we are going to learn how to reduce sets like this, set like this to its basic form. Now let's learn how to do that. Before square root of x can be reduced further, x must contain a factor which is a perfect square. So whenever you have a set like we have here, before you can reduce it any further, we are saying that the numbers under the square root sign, so in this case 20, 96 and 24, must contain a factor which is a perfect square. Now, what is a perfect square? Some examples of perfect squares have been given here. So you can see from here that perfect squares are numbers or terms that you can express them as the square of other numbers. Now this is what I mean. If you take the number 4, you can express 4 as 2 squared. If you take the number 9, you can express 9 as 3 squared. If you take the number 16, you can express that as 4 squared. So you see that you can express these numbers as the square of other numbers. These numbers are called perfect squares. Remember in a previous video that we said whenever you take the square root of the square of other numbers, you are going to get the number in question. So in this case, if you take the square root of 2, you are going to get 2. Remember, if you take the square root of 2 squared, you are going to get 2. Remember that the 2 squared is the same as 4. So if you take the square root of 4, you are going to get 2. In the same way, if you take the square root of 9, you are going to get 3. If you take the square root of 16, you are going to get 4. You are going to get 4 in this case. So you can see from here that we take the square root of these numbers and we are getting their base here. If you watch the video on indices, you realize that 5 is called the base and 2 is called the index. If you take the square root of these numbers, we are getting the base here. So if you take square root of 25, you are going to get 5. If you take square root of 36, you are going to get 6. Square root of 49, you are going to get 7. Square root of 64, you get 8. Square root of 81, you get 9. Square root of 100, you get 10. And square root of 121, you get 11. Remember that perfect squares don't end here. So 12 squared is a perfect square, 13 squared is a perfect square, 14 squared is a perfect square. So it continues up to infinity. So the point is telling us that before you can reduce square root of x to its basic form, x must contain a perfect square. So here, before we can reduce square root of 20, square root of 96, and square root of 24 to its basic form, 20 must contain a factor which is a perfect square. 96 must contain a factor which is a perfect squared, and 24 must also contain a factor which is a perfect square. Now remember these perfect squares: 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. It continues up to infinity. So 12 squared is also a perfect squared, and 13 squared is also a perfect squared. So for example, to reduce square root of 20 to its basic form, we express it as a perfect squared times another number. Remember, the number you are multiplying the perfect square with must give you the number under the square root sign. You usually get these numbers from the factors of the number under the square root sign. So here, someone will ask, where did we get 4 and 20 from? If you list the factors of 20, they are 1, 2, 5, 10, and 20. So we list the factors as 1, 2, 5, and 20. Oh, sorry, we have to add 4. So let's clean this, then we will list the factors well. So factors of 20, we are going to get 1, 2, 4, 5, 10, and 20. So we can see from here that we have 4, which is a perfect square in the factor, so we pick that perfect square. Then we look for another number that you multiply 4 with to get 20, and we know that straight away that number is 5, because 4 times 5 will give us 20. So we express what is under the square root sign as a as a perfect square times another number to give you 20 here before we can simplify. In the same way, if you want to reduce 96, square root of 96 to its basic form, you have to express this as a common factor, a perfect square times another number. In this case, the perfect square and the other number must all be factors of this number. So here, if you list the factors of 96, you see that the two numbers we are talking about are 16 and 6. In the same way, for 24, the two numbers will be 4 and 6. Remember that in this case, one of the numbers must be a perfect square. Now, sometimes finding this can be tedious. For example, for 96, if you want to use the way we used up here, you must list the factors of 96 before you pick these. So what I'm going to do is I'm going to show you how you can use your calculator to find these numbers in the next slide. So let's consider some example. We are told to reduce square root of 27, square root of 128, square root of 600, square root of 75, and square root of 125 to its simplest forms. So we begin with square root of 27. Remember, I said that before you can reduce square root of 27 to its simplest form, you have to find a perfect square which is a factor of this. Then you multiply that perfect square by a number that when you multiply, you are going to get 27, or the one under the square root sign. I'm going to teach you how to use your calculator to find those two numbers that you are going to multiply. So this is what you do. First, take your calculator, then punch the question that has been given to you here. So here you want to reduce square root of 27. So you punch square root of 27. You see the calculator is giving us 3 root 3. Now write that down. 3 root 3. So the calculator is giving us square root of 27 to be 3 root 3. The first number that you are looking for, the perfect square that you are looking for, is the square of the number in front of the square root sign. So here the perfect square we are looking for is 3 squared. The other number is the number under the square root sign, so times 3. So in this case, the two numbers we are looking for are 3 squared times 3. 3 squared is 9, so you have 9 times 3. Then from here, we know from the properties of sets that square root of 9 times 3 can be broken down to square root of 9 times square root of 3. We have seen that square root of 9 is not a set. Since 9 is a perfect square, square root of 9 will give us 3 times square root of 3. So from the properties, we know that if you have 3 times square root of 3, it is written as 3 root 3. Let's look at another example. Square root of 128. So if you want to find those two numbers, first switch on your calculator, then input the question that you have been given onto the calculator. So square root of 128 will give us 8 root 2. So if you want those two numbers, we are saying that the calculator gave us 8 root 2. So we have 8 root 2. So the first number, or the perfect square we are looking for, is the square of the number in front of the square root sign. So in this case, square root of 8 squared. I'm going to clean this. The pen is giving me some problems. Okay, so the first number you are looking for, The calculator gave us 8 root 2, right? Yeah. So the perfect square we are looking for is the square of the number in front of the square root sign. So in this case, the perfect square is 8 squared. The other number is the one under the square root sign, so a squared times 2. We know that a squared is the same as 64, so 8 squared will give us 64. So in this case, the two numbers we are looking for are 64 and 2. So we have 64 times 2 as we have here. Then from the properties of sets, we know that this can be written as square root of 64 times square root of 2. So square root of 64, since 64 is a perfect squared, square root of 64 will give us 8 times square root of 2. 8 times square root of 2 give us 8 root 2 as we have here. Let's pick another example. We have square root of 600. So punch this on your calculator. Square root of 600 will give us 10 root 6. 10 root 6. So we have 10 root 6. So what you do is that you write 10 square root of 6. So the perfect square you are looking for is the square of the number in front of the square root sign. So 10 squared. The other number is what you have under the square root sign, so times 6. So in this case, the two numbers you are looking for are, so you write your square root sign. 10 squared is the same as 100. Since 10 squared will give us 10 times 10, and 10 times 10 is 100, then you multiply that by 6. So from the properties, we know that this can also be written as square root of 100 times square root of 6. Square root of 100 will give us 10 times root of 6. 10 times square root of 6 will give us 10 root 6. Let's take the fourth example, square root of 75. So once again, you press this on your calculator. So square root of 75, we are going to have 5 root 3. So 5 root 3. The calculator is giving us 5 root 3. The first number, or the perfect square, is the square of the number you have in front of the square root sign from your calculator. So the perfect square will give us 5 squared, then times the other number is what you have under the square root sign, which is 3. So we know that 5 squared will give us 25 as we have here, then times 3. Don't forget the square root sign. So you can see from here that 25 times 3 will give us 75. So nothing has changed. From the properties, we know that this will give us square root of 25 times square root of 3. 25 is a perfect square, so you can express that as 5 squared. So you have square root of 25 to give you 5, then times square root of 3. 5 times square root of 3 will give us 5 root 3. Let's consider the last example in this video. We have square root of 125. So you press that on your calculator. Square root of 125, that will give us 5 root 5. So if you have 5 root 5, so 5 square root of 5. So the first number, or the perfect squared, is the square of the number in front of the square root sign, which in this case is 5. So you have 5 squared times the other number is what you have under the square root sign, which is 5. So in this case, the two numbers we want to be 25 and 5. So 25 times 5. Then this, from the properties, we know this to be square root of 25 times square root of 5. This will give us 5 times square root of 5, and we are getting 5 root 5. So you can see that using this trick on your calculator, you can find those two numbers with which you can reduce the set to its simplest form in a very, very easy way. Thank you for watching this video. Pick more examples on reducing sets to its basic form using the principles and the calculator trick I showed you in this video. See you in the next video, where we are going to learn how to add sets. Bye bye. We are on the topic sets. In the previous video, we looked at properties of sets, and we also saw how to reduce sets to its basic form. In this video, we are going to see how we can add sets. So, addition of sets. When adding sets, remember that two sets can only be added if the terms under the square root sign are the same. So before you can add two sets, you must make sure that the terms under the square root sign or the numbers under the square root sign are the same. And if you are adding two sets, so for example, if you are adding the set a square root of b to c square root of b, so you can see from here that the terms under the square root sign are the same. So here we have square root of b, here we also have square root of b. Now, if you have this, then you can go ahead and add the set. When you are adding, we add what is in front of the square root sign. So we add a to c, then square root of one of the terms, so square root of b. So we add what is in front of the square root sign, then we pick one of the terms under the square root sign. So a plus c, then square root of b. Remember that the terms under the square root sign must be the same. So here we have square root of b, here we have square root of b. If they are different, you can't add them. Let's pick some examples and see how this is done. So we are told to add the following, leaving our answers in set form. So you pick these one after the other and solve it. So for the first example, we have square root of 24 plus square root of 96. Now, if you have it in this way, what you have to do is that you have to first reduce these cells to its basic form, then you add. In the previous video, we saw how to reduce a cell to its basic form. We are going to continue with the explanation in this video too. So, if you want to reduce this cell to its basic form, you saw that you have to find two factors of this number, and one of those factors must be a perfect square. Then you find two factors of this number that when you multiply, you are going to get 96. One of those factors must be a perfect square. I showed you how to use the calculator to find that, and I'm going to do that once again in this video too. So first, we need to reduce square root of 24 to its basic form. Then we reduce square root of 96 to its basic form. So let's begin with 24. So you pick your calculator, then you point square root of 24 on the calculator. Now we are having 2 root 6. So the calculator is giving us 2 root 6. So the calculator is giving us 2 root 6. So you can see that the first or the perfect square that you're looking for is the square of the number in front of the square root sign. So the perfect square in this case is 2 squared. Then times the other number will be the one under the square root sign, which is 6. We know that 2 squared is the same as 4. So for square root of 24, we are going to have 4 times 6 to replace 24 here. Then let's do that for 96. So for 96, you press square root of 96. 96. The calculator is giving us 4 root 6. So the first number that you are looking for, the perfect square, is square root of 4, which is the number in front of the square root. Sorry, the square of 4, which is the number in front of the square root sign. So 4 squared will give us 16. Then the other number is 6. So you are going to have 16 times 6. So to reduce square root of 24 and square root of 96, we know that square root of 24 will give us 4 times 6, as we saw here. So we have square root of 4 times 6, as we have seen here, then plus for 96, if you are reducing it, you are going to get 16 times 6. I've shown you how to use the calculator to get these two numbers. Then you proceed from here. From the properties of sets, we know that square root of 4 times 6 can also be written as square root of 4 times square root of 6. We have the addition sign here, so you bring it plus square root of 16 times square root of 6, as we have here. Square root of 4. 4 is a perfect square, so square root of 4 will give us 2. We multiply 2 by square root of 6, and we are getting 2 root 6. Then plus square root of 16 will give us 4. You multiply that by square root of 6, we are getting 4 root 6. So you can see from here that we have reduced this to the basic form. Now we have the terms under the square root sign to be the same. So when you come here, we have square root of 6. When you come here, we have square root of 6. It means that we can add what is in front of the square root signs. So if you are proceeding, it's going to be 2 plus 4, then square root of 6. We know that 2 plus 4 will give us 6. So we have 6 root 6. Now, you can use your calculator to check if your answer is correct. All you need to do is to press square root of 24. Then you press this sign to remove the cursor from the square root sign. Then you press plus square root of 96 on your calculator. Then you press equal to, and your calculator is giving you 6 root 6 as we have here. Let's pick the next example. We have square root of 32 plus square root of 128 plus square root of 50. So once again, you press these on your calculator to give you the two numbers. So let's do it for this one too. So you press square root of 32 on your calculator. Square root of 32 is giving us 4 root 2. So the perfect square we are looking for is 4 squared, which is 16. Then the other number will be 2. So you have 16 times 2 for 32. For 128, you press square root of 128. Then you press equal to, you are getting 8 root 2. So the perfect square we are looking for is 8 squared, which will give you 64. Then the other number is 2. So you have 64 times 2 for 128. Then for square root of 50, the calculator is giving us 5 root 2. So the perfect square we are looking for is 5 squared, which is 25. The other number is 2. So for 50, we are going to have 25 times 2. So that is what we have here. We have 16 times 2 for 32. Then we have 64 times 2 for 128. We have 25 times 2 for 50. Then, if we are reducing this, this will give us square root of 16 times square root of 2 plus square root of 64 times square root of 2 plus square root of 25 times square root of 2. Square root of 16 is 4. 4 times square root of 2 give us 4 root 2 plus square root of 64 is 8. 8 times 2 square root of 2 give us 8 root 2. Then plus square root of 25 is 5. 5 times square root of 2 give us 5 root 2. So we can see from here that the terms under the square root sign are all the same. So we have square root of 2 here, we have square root of 2 here, we have square root of 2 here. So we can go ahead and add the terms in front of the square root sign. So 4 plus 8 plus 5 square root of 2. 4 plus 8 plus 5 will give us 17. So we have 17 root 2. So 4 plus 8 will give us 12. 12 plus 5 will give us 17. So we have 17 root 2. Let's pick the next example. We have 3 square root of 8 plus 3 square root of 200 plus 2 over 3 square root of 162. So here too, let's try this on the calculator and see. So once again, you tackle what is under the square root sign. So here we change square root of 8 to its basic form. We change square root of 200 to its basic form. We change square root of 162 to its basic form. So for square root of 8, we point that on the calculator and we are having 2 root 2. So the perfect square we are looking for is 2 squared. So 2 squared, then the other number is 2. We know that 2 squared is 4. So you have 4 times 2 for 8. For 200, square root of 200, we are having 10 root 2. So the perfect squared is 10 squared. We know that 10 squared is 100. Then the other number is 2. So 100 times 2 for 200. Then for 162, we punch 162 on the calculator. And we are getting 9 root 2. The perfect square we are looking for is 9 squared, which is 81. Then times the other number, which is 2. So 81 times 2 for 162. So you replace that with what you have here, as we can see from here. So we are going to have, don't forget that 3 is already in front of the square root sign. So we have 3, then square root of 8 is now 4 times 2, then plus 3 is already here. So we have 3, Then 200 will give us 100 times 2 plus 2 over 3 is already here. So 2 over 3, then square root of 162, as we have seen, is now 81 times 2. So from the properties, we know that this will be the same as 3 is already there. Now 3 is multiplying the whole of this. So 3 times, then square root of 4 times square root of 2. You break this down, then plus, we already have 3 here. So 3 times, you break this one also down, square root of 100 times square root of 2 plus 2 over 3 is already here. So times, then you break this down, square root of 81 times square root of 2. Now let's proceed. We have 3 times square root of 4 is 2. So 3 times 2 times square root of 2 plus 3 times square root of 100 is 10. So 10 times square root of 2, then plus 2 over 3 times square root of 81 is 9 times square root of 2. So we proceed. We have 3 times 2 to give us 6 times square root of 2. We have that here. So plus 3 times 3 will give us 30 times square root of 2 plus 2 over 3 times 9 will give us 6, because 3 will cancel itself 1 and cancel 9 3 times. So this is what we mean. So 3 here will cancel itself 1, cancel 9 3 times. So we have 2 times 3 to give us 6, as we have. So 6 times square root of 2. Then we proceed with our simplification. We know that 6 times square root of 2 give us 6 root 2. 30 times square root of 2 give us 30 root 2. 6 times square root of 2 give us 6 root 2. So we can see from here that all the terms under the square root signs are the same. So we can add the numbers in front. So we have 6 plus 30 plus 6, then square root of 2. This will give us 42 root 2. Sorry. Let's pick the next example. We have square root of 80 plus square root of 28 plus square root of 20 plus square root of 63. So you reduce these to its basic form, then you add. So let's look at square root of 80. We are reducing it to its basic form. You press it on the calculator. The calculator is giving us 4 root 5. So the perfect square we are looking for is 4 squared. 4 squared is 16. The other number is 5. So 80 will be replaced with 16 times 5. Then square root of 28 will give us 2 root 7. So the perfect square we are looking for is 2 squared, which is 4. The other number is 7. So we have 4 times 7 to replace 28. Square root of 20 will give us 2 root 5. So the perfect square we are looking for is 4. Since we will have 2 squared, which is 4, then the other number is 5. So 4 times 5 to replace 20. Then square root of 63 will give us 3 root 7. So the perfect square we are looking for is 3 squared, which is 9. Then the other number is 7. So 63 will be replaced with 9 times 7. Then you proceed and simplify. So 80 will give us 64 times 5, 16 times 5. 28 will give us 4 times 7. 20 will give us 4 times 5. And 63 will give us 9 times 7. You break this down, you are getting square root of 16 times square root of 5 plus square root of 4 times square root of 7 plus square root of 4 times square root of 5 plus square root of 9 times square root of 7, as you can see here. This will give us 4 root 5. You simplify this, we get 4 root 5. You simplify this, you get 2 root 7. You simplify this here, you get 2 root 5. And you simplify this here, you get 3 root 7. Now you can see from here that some numbers under the square root sign, in this case, some of the numbers under the square root sign are 5, others are 7. So you group the 5 together, then you group the 7s together. If you are grouping them, you have square root of 5 plus, we have 4 root 5 plus 2 root 5, then you group the 7s also together. So you have 2 root 7 plus 3 root 7. So here we can see that the numbers under these square roots are the same. So you have square root of 5 here, square root of 5 here. So you can add what is in front. Here, when you come here, you have square root of 7 here, you have square root of 7 here, so you can add what is in front. So you add for this part. So you have 2 plus 4 plus 2 root 5, then plus, when you come here, you have 2 plus 3 root 7. So 4 plus 2 will give us 6, so you have 6 root 5. 2 plus 3 will give us 7, it will give us 5, so you have 5 root 7. Now when you come here, you can see that this is square root of 5, this is square root of 7. Since they are not the same, you can't add, so you end here. Thank you for watching this video on addition of sets. Pick more examples and follow the same principles that we have used in this video. See you in the next video where we will tackle subtraction of sets. Bye bye. We are still on the topic sets. In the previous video, we looked at how to add sets. In this video, we are going to look at how to subtract sets. So let's see how this is done. Subtraction of sets. Just as it is for addition, two sets can be subtracted only if the terms under the square root sign are the same. So as we can see from this example here, if you have a root b minus c root b, you subtract the terms in front of the square root sign. So you are going to have a minus c, then you pick one of these, root b, you pick one of them, so root b. So before you can subtract, make sure that the numbers under the square root signs are the same. So here we have square root of b, we have square root of b, so you can subtract c from a. Let's pick some examples and see how this is done. So we are told to evaluate the following, leaving our answer in set form when necessary. So you pick them one after the other. The first one, we have square root of 80 minus square root of 45. Just as we did for addition, when you are being given this, you have to reduce these sets to its basic form, then you proceed with the subtraction. So we first reduce square root of 80, then after that we reduce square root of 45. Now let's see how this is done. We have been doing this all along, so you should be conversant with it by now. So we do square root of 80. The calculator is giving us 4 root 5. So the perfect squared we are looking for is 4 squared, which is 16. The other number is 5. So you place 80 with 16 times 5. For 45, square root of 45 will give us 3 root 5. So the perfect square we are looking for is 9, which is 3 squared. Then the other number is 5. So 9 times 5 will give us 45. Then you proceed with the simplification as we have here. So we replace 80 with 16 times 5. Then you replace 45 with 9 times 5. Now you expand this. So you are going to have square root of 16 times square root of 5 minus square root of 9 times square root of 5. Then square root of 16 will give us 4. So 4 times square root of 5 will give us 4 root 5. Square root of 9 will give us 3. Don't forget the negative signs already here. So minus 3, then square root of 5. Now we can see from here that we have square root of 5. We have 5 under the square root sign. We have 5 under the square root sign, so we can subtract the numbers in front. So we are going to have 4 minus 3, then square root of 5. This is giving us 1 root 5, and whenever you have 1 root 5 is the same as square root of 5. If you want to check whether your answer is correct, you can try this on the calculator. So you press square root of 80. Now after you've done this, you see the cursor is under the square root sign, so you have to press this button here so that the cursor will be moved from the square root sign. Then minus square root of 45. So square root of 45, you press equal to, and you can see from here that we are having square root of 5 as we solved here. Let's pick the next question. We have square root of 24 minus 3 root 6 minus square root of 216. So let's break this down to its simplest form. So let's pick the first one, square root of 24. So 24 will give us 2 root 6. So the first term we are looking for or the perfect square we are looking for is 2 squared, which is 4. The other number is 6, so 4 times 6, you replace that with 24. Now when you come here, 3 is already here. We don't have to worry about. What you have to worry about is the number under the square root sign. You check and see if it is in its simplest form. Now we are checking to see if square root of 6 is in its simplest form. You see, when you point square root of 6 on the calculator, it gives you square root of 6. It means that it is in its simplest form, so we don't have to worry about that. We leave that. Then we move on to the next one. We have square root of 216. So square root of 216, and the calculator is giving us 6 root 6. So the perfect square you are looking for is 6 squared, which is 36. The other number is 6. So we replace 216 with 36 times 6. So you do that, then we proceed to simplify. So we have 24 being 4 times 6. Then this is in its simplest form, so you leave it like that. So minus 3 root 6, then minus 216 will give us 36 times 6. So you expand this. We have square root of 4 times square root of 16 times square root of 6, minus 3 root 6 minus square root of 36 times square root of 6. Square root of 4 will give us 2, so 2 times root 6 will give us 2 root 6, then minus 3 root 6 minus square root of 36 will give us 6, so 6 times square root of 6 will give us 6 root 6. So from here you can see that the number under the square root sign is 6, the one here is 6, the one here is also 6, so we can subtract the numbers in front of the square root sign. So we are going to have 2 minus 3 minus 6, then square root of 6. 2 minus 3 minus 6 will give us minus 7 root 6. So you can also try this on the calculator and check your answer to see whether you are correct. So you have square root of 24. Now once again, the cursor is under the square root sign, so you press this button to remove it from there, then minus 3 root 6. The cursor is still there, so you press this button to remove it from there, then minus square root of 216, press equal to, and we are getting negative 7 root 6 as we have here. Let's move on to the next example. We have square root of 112 minus square root of 2 minus square root of 63. So you reduce this to its basic form. This is already in its basic form. You can't reduce it any further, so you leave it. Then you reduce this one also to its basic form. So let's begin with the first one. We have square root of 112. The calculator is giving us 4 root 7. So the perfect square we are looking for is 16. Since 4 squared is 16, the other number is 7. So 16 times 7 we replace 112. Then since square root of 2 is in its basic form, you don't worry about that. You move on to the next one, which is square root of 63. Square root of 63 is giving us 3 root 7. So the perfect square we are looking for is 3 squared, which is 9. The other number is 7. So you replace 63 with 9 and 7. So square root of 112 will give us square root of 16 times 7, then minus square root of 2, which is already there, then minus square root of 63 is now 9 times 7. So you expand this, you are going to get square root of 16 times square root of 7 minus square root of 2 minus square root of 9 times square root of 7, which is the expansion for this. Square root of 16 will give us 4, then times root of 7 will give us 4 root 7. Then minus square root of 2 minus square root of 3, square root of 9 will give us 3. Don't forget the negative sign is already here, then root 7. Now you can see that this one and this one are like terms. The terms under the square root signs are the same, so you group them to one side. So we have 4 root 7 minus 3 root 7, then minus 2, which is the unlike term. Don't forget that you can only subtract when the numbers or the terms under the square root signs are the same. So in this case, you can only subtract these two. You can do the operation for just these two. So we are having 4 minus 3, then root of 7 minus square root of 2. 4 minus 3 will give us 1. So we are going to have 1 root 7, which is the same as root 7, then minus square root of 2. Now, since the number here is 7 and the number here is 2, we can't do the simplification any further, and this will be our final answer. Let's look at the last question. We have square root of 2 plus square root of 50 minus square root of 18. So we reduce these ones to its basic form, since square root of 2 is already in its basic form. So square root of 50, you should be conversant with this by now. So square root of 50 will give us 5 root 2. Now 5 is the same, 5 in this case the perfect square we are looking for is 5 squared, which will give us 25. So you replace 50 with 25 times 2. Then for 18, square root of 18, we are going to have 3 root 2. So the perfect square we are looking for is 9, which is 3 squared. So 9 times 2 will replace 18. So we do that. We already have square root of 2 in this basic form, so we don't worry about that. So square root of 2 plus square root of 50 is now 25 times 2, then minus 18 is now 9 times 2. Then you expand this, we have square root of 2 here, which is already there. Then we have square root of 25 times square root of 2 minus square root of 9 times square root of 2. So we have square root of 2 plus 5 root 2. Since square root of 25 is 5, 5 times square root of 2 give us 5 root 2, then minus 3 root 2 for this part. So square root of 9 give us 3 times 2 give us 2 times root 2 give us 3 root 2. Don't forget the negative sign already here, so you have that there. So you can see from here that the number under the square root sign is 2, the number under the square root sign is 2, the number under the square root sign is 2. So you can proceed with the operation. So here is addition, here is subtraction. So you do it just like that. Don't forget that this number here, square root of 2, has no number in front of it, which means that the number there is 1. So this one is the same as 1 root 2. 1 root 2 is the same as root 2. So the next step is going to be 1 plus 5 minus 3, then square root of 2. Since all the numbers under the square root sign are the same, you can add and subtract. So you're going to have 1 plus 5 minus 3, then square root of 2. 1 plus 5 will give us 6. 6 minus 3 will give us 3. So we have 3 root 2, as we can see from here. So you can also try and see if you will get this on your calculator. So you can point square root of 2, then you press this to remove the cursor from the square root sign, then square root of 50, press this, then minus square root of 18. You press equal to, and you are getting 3 root 2 as we have here. So you can see from this that whenever you have a question, and after you finish solving the question, you can actually use your calculator to check whether your answer is correct. If it's incorrect, check through your procedure and see where you made the error. Thank you for watching this video. Take more examples on addition and subtraction on sets. See you in the next video where we will learn how to multiply sets. Bye bye. We are on the topic sets. In the previous video, we learned how to add and subtract sets. In this video, we are going to learn how to multiply sets. So, multiplication of sets. Now, you remember from the video on properties of sets that if you are multiplying sets, you have to obey these properties. So I entreat you to remember, take note of these properties. If you have a root b multiplying c root d, what is in front of the square root sign will multiply. So a will multiply c, then what's under the square root sign will also multiply. B will multiply d. It follows for all these. So if you have square root of a multiplying square root of b, you are going to have square root of ab. If you have a multiplying square root of b, you have a root b. If you have a root b multiplying square root of c, you are going to have a root bc. Then if you have a multiplying b root c, you are going to have a times b square root of c. So let's pick some examples and see how we can apply these properties when solving the question. So we are being told to evaluate the following. You take them one after the other, then you solve. So let's pick the first one. Sorry. We have square root of 18 times square root of 75. Now we can see from here that these ones are not in their basic forms. So we reduce them to its basic form as we have been doing all along. So you will know that if you are breaking 18 down, we are going to have 9 times 2. Then the multiplication sign is already here, so we bring that. Then square root of 75 will give us square root of 25 times 3. In previous videos, I've explained how to use the calculator to get these two numbers. So if you watch that video, you see how these numbers were derived. Now, we expand this. So we are going to have square root of 9 times square root of 2 times square root of 25 times square root of 3. We know that square root of 9 will give us 3, then times square root of 2. So we have 3 root 2 times square root of 25 will give us 5. So we have 5 root 3, as you can see here. So from here, we can see that this is now in its basic form. So we can multiply. So when multiplying, we multiply the numbers in front of the square root sign. So 3 will multiply 5. Then square root of the numbers under the square root sign will multiply. So 2 will multiply 3. So unlike addition and subtraction, for multiplication, even when the numbers under the square root sign are not the same, we can still multiply. So we multiply the numbers in front of the square root sign, 3 times 5. Then the numbers under the square root sign multiply. So 3 times 2 times 3. 3 times 5 will give us 15. Then square root of 2 times 3 will give us 6. So you can try this on your calculator and you see that square root of 18 times square root of 75 will give us 5 root 6. Let's pick the next one. We have square root of 20 times square root of 5 raised to the power 3. Now we know from indices that if you have a number like this, like maybe x raised to the power 3, sorry, I'm going to clean this so that I'll write it well. So the eraser, pick the eraser and clean this so that I'll write it well for you to see. If you have a number like this, so we have this number, sorry, s raised to the power 3 is the same as s times x times x. Okay, so s raised to the power 3 will give us x times x times x, as we can see from here. So in the same way, if you have s raised to the power 3, we know that we are going to get x times x times x. In the same way, square root of 5 raised to the power 3 will give us, so if you expand this, you are going to have square root of 20 times. This will repeat itself 5 times, just as we have here. So square root of 5 times square root of 5 times square root of 5. Now square root of 5 is already in its basic form. So what we have to do is to break square root of 20 to its basic form. Now if you are breaking for 20, the perfect square will be 4. Then the other number will be 5. So 4 times 5 will give you 20. Then we have this here. So square root of 5 times square root of 5 times square root of 5. Now let's expand this. If you're expanding this, we are going to have square root of 4 times, then square root of 5 times these three. So square root of 5 times square root of 5 times square root of 5 times square root of 5. We know that square root of 4 will give us 2. Now from the properties of sets, we know that square root of 5 times square root of 5 will give us 5. So we are going to have times 5. Now when you come here to, we have square root of 5 times another square root of 5. So square root of 5 times square root of 5 will also give us 5. So this is what it means. Square root of 4 is giving us 2. We have the multiplication here. But we know that square root of 5 times square root of 5 is 5. So you have that here. Then this multiplication sign will come. Square root of 5 times square root of 5 again will also give us 5. So to find this, we know that we are going to have 2 times 5 times 5 to give us 50. You can also try this on your calculator and you will see that the answer the calculator will give us will be 50. Let's move on to the next example. We have 2 root 3 into brackets 2 minus square root of 3 plus 3 root 2 into brackets square root of 2 minus 1. So what you do here is that you use the distributive property and you distribute what is outside the bracket over what is inside the bracket, as we did in algebra. So we are distributing what is outside the bracket over what is inside the bracket. So let's begin with the first one. The term here is 2 root 3. So you multiply that with the first term here. So 2 root 3 times the first term here, which is 2. Then after you close the brackets, you bring your addition sign. Then you open another bracket. We have 2 root 3 multiply the term inside the bracket, which is negative root 3. So 2 root 3 times minus root 3 in one bracket. So you finish with the first bracket. Then you bring your addition sign again. As I told you in algebra, whenever you close the bracket like this, if you're expanding binomials and you close the bracket like this, you bring your addition sign. Then you move on to the next one. We have 3 root 2 times the first term here, which is root 2. So 3 root 2 times root 2. You bring your addition sign. Then what is outside the bracket again? 3 root 2 times what is inside the bracket, which is minus 1. So minus 1. Then from here, we multiply what is inside the bracket. 2 root 3 times 2. From the properties of sets, we know that 2 root 3 times 2 will give us 2 will multiply 2, then square root of 3. Then plus, when you come here, we know the sign in front of this negative, in front of this one here is negative. The number there is 1. So we are going to have 2 times minus 1. Then square root of the numbers under the square root sign will multiply. So 3 will multiply 3 here. Then plus, we come to this side. 3 root 2 times square root of 2 will give us the number in front of this side here. Square root of 2 is 1. So 3 will multiply 1. So we have 3 times 1. Then square root of the numbers under the square root sign will multiply. So 2 times 2 as we have here. Then when you come here, plus, we move on to this. 3 root 2 times minus 1 will give us 3 will multiply minus 1, which is the number here. Then square root of 2 will come. So let's simplify. We know that 2 times 2 will give us 4. So you have 4 root 3. Then when you come here, 2 times negative 1 will give us negative 2. Then square root of 9. Now remember this one, the sign here is plus, here is minus. So when plus and minus meet like this, it changes to minus. So you have minus 2 root 9, because 3 times 3 will give us 9. Then we move on to this side. Here is already positive. 3 times 1 is also positive. So you have positive. 3 times 1 will give you 3. 2 times 2 will give us 4. So we have 3 root 4. Then here is positive, but 3 times minus 1 will give us negative 3. So this will change to negative. So we have negative 3 root 2. Then from here we simplify further. We have 4 root 3 minus. We know that square root of 9 will give us 3. So we have negative 2 times 3. Then plus 3 root 4. We know that square root of 4 will give us 2. So 3 times 2. Then minus what we have here, 3 root 2. Now 4 root 3, negative 2 times 3 will give us negative 6. Plus 3 times 2 will give us positive 6. Then minus 3 root 2. So you can see from here that we have negative 6 and positive 6. So they are going to cancel out. So negative 6 will cancel out positive 6. So finally, we are going to get our answer as 4 root 3 minus 3 root 2. So if you follow the procedure carefully, make sure that you don't miss any of the signs Where it's negative, you indicate it as negative. Where it's positive, you indicate it as positive, and you follow the procedure carefully. You must arrive at this answer: 4 root 3 minus 3 root 2. You can see from here that we can't simplify any further because this is subtraction, and the number under the square root sign is 3, but the number under the square root sign is 2. Remember that you can only add or subtract cells when the numbers under the square root sign are the same. So here will be this will be our final answer. Let's take the next example. We have 2 plus square root of 3 in one bracket, then square root of 3 plus 1 in the other bracket. So when you have this, all you need to do is to distribute what you have in the first bracket over what you have in the second bracket. So in the first bracket, we have 2. So you pick the first term, you distribute it over this. So you have 2, then you multiply it with everything in the second bracket. Then you pick the second term, which is plus 3, and you distribute it over everything in the next bracket here. In the second bracket, which is square root of 3 plus 1. So 2, you multiply it with everything here. Square root of 3, you multiply it with everything here, as you can see. So from here, we open the bracket. So you are going to have 2 times square root of 3 in one bracket, then plus 2 times 1 in the other bracket, then plus square root of 3 times square root of 3 in one bracket here, then plus square root of 3 times 1 in the other bracket. So you distribute what is here, the first term over everything here, you distribute the second term over everything here, then you open the brackets using the distributive rule. So 2 times square root of 3 plus 2 times 1. You finish with this bracket, you move on to the next one. Square root of 3 times square root of 3 in this bracket, then square root of 3 times 1 in the other bracket. So you do the multiplication. 2 times root 3 will give us 2 root 3. 2 times 1 will give us 2. Square root of 3 times square root of 3 will give us 3. From the properties of sets, we said that square root of x times square root of x will give us s. So square root of 3 times square root of 3 will give us 3. Then plus square root of 3 times 1 will give us square root of 3. Any number multiplied by 1 is the same number. So we group the numbers at one side, then we group the cells at another side. So this is a set, this is also a set. We group them, then we group the numbers. 2 plus 3 will give us 5. So square root of 2 root 3 plus root 3 will give us plus 5. So we add 2 root 3 to root 3. Don't forget that the number in front of this set here is 1. So square root of 3 is the same as 1 root 3. So if you are adding, you are going to have 2 plus that number here, which is 1, then square root of 3, then plus 5. 2 plus 1 will give us 3, so you have 3 root 3 plus 5. So that is the answer for this. We move on to the next example. We have square root of 3 minus 1 in one bracket, 2 minus square root of 3 in the other bracket. So just as we did for the previous example, in this example too, we are going to do the same thing. Remember, you can see from here that all these are in this basic form, so we don't have to reduce anything. So we share square root of 3 over what is here, then we share negative 1 over what is here. So let's do that. We have square root of 3, then times what is in the second bracket, 2 minus square root of 3. Then we take the second term, minus 1. We open a bracket for this, so we have 2 minus square root of 3. Then we do the expansion. So we are going to have square root of 3 times 2 in one bracket. Then you bring your addition sign, so plus square root of 3 times negative root 3 in this bracket. Then plus, when you come here, the sign outside is negative 1. So negative 1 times what is here, which is positive 2. So negative 1 times 2. Then plus, you open another bracket again. Negative 1 times negative root 3 in this bracket. So remember that when you close the bracket, you bring your addition sign. Then you multiply the term outside the bracket with the term inside the bracket. So here we have square root of 3 times 2 in one bracket, then you bring your addition sign, The term outside the bracket is root 3. You multiply it with the term here, which is negative root 3. Then plus, you open another bracket here. The term outside is negative 1. You multiply that with the first term here, which is 2. Then plus, the term outside the bracket is negative 1. You multiply that with the term inside the bracket, which is negative root 3, as we have here. Then we move on. We know that square root of 3 times 2 will give us 2 root 3 from the properties of sets. We know that square root of 3 times square root of negative 3 will give us negative 3, because square root of 3 times square root of 3 will give us 3. There's a negative sign here, so negative. So we have that to be negative 3. Then when you come here, negative 1 times 2 will give us negative 2, as we have here. Then plus negative 1 times negative root 3. We know that when negative multiplies negative, it changes to positive, so positive root 3. So we group the numbers at one side and we group the sets at the other side. So we have 2 root 3 plus square root of 3 minus 5. You know that the number in front of this root 3 sign here is 1. So if we are adding them, we are going to have 2 plus 1 square root of 3 minus 5, and this will give us 3 root 3 minus 5. Remember, you can't add this set here to the whole number here. Now we can see from this example that after we solved it, we are having a set in the final answer. In the next video, we are going to take examples where after we solve the whole thing and we have arrived at this answer, the set will be given to us as an approximation, and we will have to find our final answer in terms of decimals. See you in the next video, where we will take examples on questions such as those. So the set in the question will be given to us as an approximation, and we use that to evaluate our answer and find it in terms of decimals. Bye-bye. We are on the topic sets, and we are going to treat multiplication of sets today. In the previous video, we looked at some examples on multiplication of sets, and in this video too, we are going to take some more examples on multiplication of sets. So we are being told to evaluate 1 square root of 3 into bracket 4 plus square root of 3 if square root of 3 is equal to 3.606. So this was what I meant in the previous video. Now you can see from here that in this case, the set has been given to us as an approximation. Square root of 3 has been given to us as 3.606, and we are being told to evaluate this. The same thing applies to this. Then when you come here, this binomial has been given to us, and we are being told to find the value of x and y. Now we are going to see how to go by this. So let's begin with the first one. Evaluate square root of 3 into bracket 4 plus square root of 3 if square root of 3 is equal to 3.606. Now when the question is given to you in this way, don't substitute 3.606 into the expression straight away. That will give you a wrong answer. What you have to do is to first multiply the expression and simplify it to its simplest form, and simplify it so that you can substitute this into your final answer. Now this is what I mean. When you have, this is the expression given to us, so what you have to do is to do the multiplication, then you reduce it to its simplest form before we substitute square root of 3 into the final answer. So here we know that square root of 3 into bracket 4 plus root 3, square root of 3 will multiply 4 as we have here. So you have square root of 3 times 4, then plus square root of 3 times square root of 3 as we have here. This will give us 4 root 3, because square root of 3 times 4 give us 4 root 3. Then plus square root of 3 times square root of 3. From the properties of sets, we know that that will give us 3. So you can see that we have now reduced this to its simplest form. From here, you can now substitute this into it straight away. So what you do is that we know that square root of 3, here will give us 3.606. So square root of 3 is giving us 6.606. That's what the question told us. So you replace square root of 3 here with 3.606. So it's going to give us 4 times 3.606 then plus 3 as we have here. So 4 times 3.606 will give us, so 4 times 3.606 will give us 14.424. So you are going to have 14.424 plus 3. So 14.424 plus 3 will give us 17.424, as you can see here. So we have 17.424. So whenever something like this has been given to you, what you have to do is to first reduce it to its simplest form. Then you substitute the surd into your final expression. So in this case, our final expression was 4 root 3 plus 3. So you substitute square root of 3 into the final expression, as you can see from here. So we move on to the next one. We have 3 root 7 into bracket 7 minus 2 root 7. So you first do the multiplication, then you move on. So, sorry. So we have 3 root 7 or multiply 7, as we have here. So 3 root 7 times 7. Then plus, what is outside the bracket is 3 root 7. What's inside the bracket is minus 2 root 7. So we have 3 root 7 in one bracket, then plus 3 root 7 times minus 2 root 7 in the other bracket. 3 root 7 will give us 21 root 7. It should be conversant with this by now. Now when you come here, we are doing multiplication. So what is in front of the square root signs will multiply. So 3 will multiply 2 to give us, will multiply negative 2 to give us negative 6. Then times what is under the square root sign will multiply. So you are going to have square root of 7 multiplying square root of 7. You know that square root of 7 times square root of 7 will give us 7. So you have 3 times negative 2 to give us negative 6. Then times square root of 7 times square root of 7 to give us 7. So you are going to have 21 root 7 minus 6 times 7 will give us 42. Don't forget the negative here, so we have negative 42. Now as you can see, this is in its simplest form. Since square root of 7 can't be reduced any further, so you can now substitute this in here. So we have 21 times square root of 7 has been given to us as 2.646. So 21 times 2.646 minus 42. 21 times 2.646 will give us 55.566, then minus 42. So you punch this on your calculator, you're going to get 55.566 minus 42. Then 55.566 minus 42 will give us 13.566. So the value of this is 13.566. Remember that if the question, you are being given the question and this has not been given to you, please always leave your answer in a surd form. You can only substitute this in your final expression when it has been given to you in the question. But if the question does not give it to you, leave your answer in the surd form. Let's pick the next example. The question is saying that if 1 minus square root of 3 in one bracket 1 over 3 plus square root of 3 is equal to x plus y root 3, find the value of xy. Now when you are being given a question like this, all you need to do is to first multiply these two binomials that you have been given, then express your answer in this form. Now this is what I mean. Let's first begin with the multiplication. So you multiply this by this. It's the same binomial that we are doing. So you distribute what is in the first bracket over everything in the second bracket. So you take the first term, you multiply it with everything here. You take the second term, you multiply it with everything here, as we can see. So 1 times 1 over 3 plus square root of 3, then minus square root of 3, we open a bracket 1 over 3 plus square root of 3. So we begin with the multiplication. We have 1 times 1 over 3 here, then plus 1 times square root of 3 here, then plus what is outside the bracket here is minus square root of 3. So minus root 3 times 1 over 3 in here, then plus when you come here you have minus root 3 times what is here, which is plus root 3. So we move on. 1 times 1 over 3 will give us 1 over 3. 1 times square root of 3 will give us square root of 3. Now when you come here, we have minus square root of 3 times 1 over 3, and that is giving us minus 1 over 3 square root of 3. Then minus, we know that square root of 3 times square root of 3 will give us 3. We already have the negative sign here, so minus 3. So you can see from here that we have numbers, then we have the sets. So you group the numbers, then you group the sets to as one side. So let's begin with the numbers. We have 1 over 3, we have minus 3 here, so 1 over 3 minus 3. Then we group the sets to at one side. So we have plus square root of 3 minus 1 over 3 square root of 3. So 1 over 3 minus 3 in one bracket for the sets. Then when you come here, you have 1 in front of this bracket. Now since the number here is 3 and the number here is 3, we can subtract them. So we have 1 which is in front of this bracket minus 1 over 3 which is in front of this bracket, then square root of 3. Remember that you can only subtract sets when the numbers under the square root sign are the same. Here the number here is root 3, the number here is root 3, so we can subtract them. So we have 1 minus 1 over 3, then square root of 3. So from fractions, we know that 1 minus 3, 1 over 3 minus 3 will give us minus 8 over 3. So you do this fraction and you are going to get minus 8 over 3. Then plus, when you come here, 1 minus 1 over 3 will give us 2 over 3. So from fractions, we know that 1 minus 1 over 3 will give us 2 over 3. Then square root of 3, as you can see from here. Now look at something. You can see from here that the question said this one is equal to s plus y root 3. What it means is that express it in such a way that you are going to have a number plus another number root 3. And that is exactly what we have done. We are having minus 8 over 3, which is a number, plus 2 over 3, which is the other number, then square root of 3. So what you can do from here is that you compare what the question gave you to your answer. So we are comparing, and when you compare, you can see that x is giving us minus 8 over 3. S represents the first number, which is minus 8 over 3. And y represents the number in front of root 3. The number in front of root 3 is 2 over 3. So y will give us 2 over 3. So when the question is given to you in this way, all you need to do is to first expand the bracket, then you simplify, and you compare your final answer with what the question gave you. So after comparing, we know that x will give us minus 8 over 3 and y will give us 2 over 3. Thank you for watching this video on multiplication of sets. Please pick more examples on multiplication of sets and try your hands on them. Use the same principles and the calculator tricks I've shown you in the videos to solve it. If you still have any problem, interact with me on my social media handles on Facebook at Math Center and on Instagram at mathcenter_shs. See you in the next video where we will tackle division of sets. Bye bye. We are on the topic sets. In the previous video, we looked at multiplication of sets. In this video, we are going to look at division of sets. So how do we divide sets? When dividing sets, we have to remember that if you have square root of x dividing square root of y, is going to give us square root of x divided by y. So for example, if you have square root of 3 dividing square root of 2 divided by square root of 3, we are going to have square root of 2 divided by 3. If you watch the video on properties of sets, you will see that this is one of the properties. Now let's pick some examples and see how this is done. So the question is telling us to evaluate the following, and you have been given from question 1 up to question 4. So we take them one after the other. Let's pick the first one. We have square root of 8 plus square root of 32 minus square root of 50 divided by square root of 2 plus square root of 18. So we can see from here that some of them are not in its simplest form. So we reduce those that are not in its simplest form to the simplest form. Now, we have been doing this a lot, and I assume you are conversant with it by now. So we reduce 18. When reducing 18, we are going to have 4 sorry, you reduce 8. In doing that, you are going to have 4 times 2 for 8. For 32, you are going to have 16 times 2. And for 50, you are going to have 25 times 2. 2 is already in its simplest form, so we don't touch it. Then we go on to 18. In reducing 18, you are going to have 9 times 2. So this will give us square root of 4 times square root of 2 plus square root of 16 times square root of 2 minus square root of 25 times square root of 2 divided by square root of 2 plus square root of 9 times square root of 2. Now, if you watch previous videos on reduction of cells to its basic form, you understand how we got these numbers here. So this will give us square root of 2 will give us 2 times root 2 will give us 2 root 2. Then square root of 16 will give us 4 times square root of 2 will give us 4 root 2 minus square root of 25 will give us 5 times square root of 2 will give us 5 root 2 divided by, we already have square root of 2 here, then plus square root of 9 will give us 3 times square root of 2 will give us 3 root 2. Now you can see from here that the signs under the square root sign are the same. The numbers under the square root sign are the same. So we have 2 here, we have 2 here, we have 2 here. So we can add the numbers in front of the square root sign. When you come here to, we have 2 here, we have 2 here. So we can also add the numbers in front of the square root sign. Don't forget that square root of 2 has 1 in front of it. So if you are adding, we are going to get 2 plus 4 minus 5, then root 2. All over, 1 is in front of this sign, so we have 1 plus 3, then root 2. Now 2 plus 4 will give us 6, minus 1 will give us, minus 5 will give us 1, so we have 1 root 2, then 1 plus 3 will give us 4, then square root of 2. Now we can see from here that this is the same as 1 over 2 times, then a bigger square root 2 divided by 2, because you are going to have square root of 2 over square root of 2. You know that square root of 2 over square root of 2 give us square root of 2 divided by 2. Now 2 will cancel 2 to give us 1. So you are going to have square root of 1. Square root of 1 is 1. So you are going to have 1 over 4 times 1, which will give us 1 over 4. Now if you try doing this on your calculator, you see that the final answer is going to give us 1 over 4. So let's try and use our calculator to confirm our answer. So to do that, press this fraction button. Then your first one, you have a square root of 8. After you've done that, press this sign to remove the cursor from the square root sign. Then press plus square root of 32. Then you press this one to remove the cursor from the square root sign, minus square root of 50. You see, we are done with the numerator, so you press this sign to move it to the denominator. Then square root of 2, then you press this sign to remove it from there, then square root of 18. So you press this on your calculator, and the calculator is giving us 1 over 4 as we have here. So whenever you finish with something like this, you can use your calculator to confirm your answer. Now let's move on to the next one. We have square root of 15 times square root of 27 minus 2 over square root of 3. So what you have to do now is to distribute what is outside the bracket over what is inside the bracket. So we have square root of 15 times square root of 27 in one bracket, then plus square root of 15 times negative 2 over root 2 as we have here. So we learned from cells that when you are multiplying, you multiply the terms under the square root sign. So 15 times 27 will give us 405. So square root of 405. Then minus 15 times negative 2 over 3 will give us 2. Will multiply this, so you are going to have 2 root 15 divided by square root of 3. Now don't forget that there's a negative sign here, so the negative is going to come here. So from here we have to reduce this set here to its basic form. So in doing that, you press on your calculator square root of 405. So the perfect square you are looking for is 9 squared. We know 9 squared is 81. the other number is 5. So to reduce 405, you are going to have 81 times 5 under the square root sign. So that is exactly what we are going to have here, 81 times 5 under the square root sign. Now from here we can see that the number in front of this square root here, square root of 3 here is 1. So you are going to have 2 over 1 times. Now we have the sets dividing, so square root of 15 divided by square root of 3. Now you can see from here that we haven't changed anything, because 2 times square root of 15 will give us 2 root 15. 1 times square root of 3 will give us root 3. So we haven't changed anything. So here the number in front here is 1. So we have 2 divided by 1 times square root of 15 divided by square root of 3, as we have here. So we reduce this further, expanding this, we are going to have square root of 15 times square root of 5, then minus 2 divided by 1 will give us 2, then times, when you are dividing this set, we know that square root of 15 divided by square root of 3 will give us square root of 15 divided by 3. So here 3 will cancel itself 1 and cancel 15 5 times. So we are going to have square root of 9 of 81 will give us 9. So we have 9 times square root of 5, which will give us 9 root 5. Now when you come here, 3 will cancel itself 1 and cancel 15 5 times. So this is going to give us, this whole thing is going to give us square root of 5. So we have negative 2 times 5, square root of 5 to give us negative 2 root 5. So you can see from here that the numbers under the square root sign are the same. So we can subtract the numbers in front of the square root sign. So we have 9 minus 2, which will give us 7, then root 5. We have done a lot of addition and subtraction in these videos on sets, so you should be conversant with these operations now. Let's look at the next one. We have square root of 10 into bracket square root of 45 plus 3 over square root of 5. So once again, we use the distribution rule. So we distribute what is outside the bracket over what is inside the bracket. So for square root of 10 times square root of 45 in one bracket, then plus square root of 10 times 3 over square root of 5. So from here we know that you multiply what is under the square root sign. So square root of 10 will multiply square root of 45. We are going to get square root of 450, then plus square root of 10 times 3 over square root of 5 will give us 3 times square root of 10 all over square root of 5, because you know that square root of 10 is divided by 1. So square root of 10 will multiply 3 to give us 3 root 10. 1 will multiply square root of 5 to give us square root of 5. So we simplify from here. So from here we are going to simplify square root of 450. So square root of 450, the calculator is giving us 15 root 2. So the perfect square we are looking for in this case is 15 squared. We know that 15 squared is 225. The other number is 2. So square root of 450, if you are to break them down, we are going to have square root of 225 times 2. Then so you do that. So you are going to have square root of 225 times 2, then plus, we have 3 here, so 3 times, you can write 3 over 1 or 3 is the same thing. So 3 times, we know that square root of 10 divided by square root of 5 can be written as square root of 10 divided by 5. Then you do the expansion here, so you have square root of 225 times square root of 5, square root of 2 here, then plus 3 times 5 will divide 10 2 times, so you are going to have square root of 2 here. So you know that square root of 225 will give us 15. You multiply that by square root of 2, we have 15 root 2, then plus 3 times square root of 2, since 5 will cancel itself 1 and cancel here 2 times. So 3 times square root of 2 give us 3 root 2. So the numbers under the square root sign, here is 2, here is 2, so we can add. So we add 15 to 3 and we are going to get 18 root 2. Once again, you can also try this on your calculator and see, and you see that the calculator will give you the same answer as we have here. So for example, if you are trying this, you are going to have square root of 10. You press this sign to remove the cursor from there, then you bring this square root of 45, then you press this again to remove the cursor, then plus you bring the fraction sign, so 3, then you press this so that you can write for the denominator square root of 5. Now from here you press this, remove the cursor to this side, you press this bracket equal to, and we are having 18 root 2 as we have here. So whenever you finish solving the question, you can use your calculator to check your answer. And if it's an objective test, you can just use the calculator to find the answer without going through all the stress. We pick the last example. We have 1 over square root of 3 into bracket 2 root 3 minus 1 over root 3. So once again, we open the bracket with this. So we multiply what is outside the bracket with what is inside the bracket. So we have 1 over 3 times 2 root 3 here, then plus 1 over 3 times minus 1 over root 3. Then we do the multiplication. So 1 times 2 root 3 divided by square root of 3 times 1. Since this whole part here is divided by 1, so this whole part, this whole place is being divided by 1. So this will give us 1 times 2 root 3 here, then square root of 3 times 1, just as we did when we were doing fractions. Then plus, we are treating what is inside the bracket here. So 1 times negative 1 as the denominator, then square root of 3 times square root of 3. We know that 1 times 2 root 3 will give us 2 root 3. Square root of 3 times 1 will give us square root of 3. Then minus, since you have the minus here, you bring it here. Minus 1 times 1 will give us 1. So you can see from here that this will give us 1 times minus 1 give us minus 1. So the negative will now come outside here to give us minus 1 over square root of 3 times square root of 3 will give us 3. From the properties of sets, we have seen that. Now we can see from here that we have 2 root 3 divided by root 3. So someone can say that root 3 will cancel root 3. So square root of 3 here will cancel square root of 3 here to give us 2. Then we have minus 1 over 2. In the same way, this one is also the same as 2 square root of 3 divided by 3. So that the 3 will cancel the 3 to give us 1. So we are going to get 2 square root of 1. And we know that square root of 1 is the same as 1. So 2 times 1 will give us 2, then minus 3. Now if you perform this fraction, if you perform this operation 2 minus 1 over 3, we are going to get 5 over 3. If you want to understand how this is done, watch the video on addition and subtraction of fractions and you see how we got 2 minus 1 over 3 to be 5 over 3. Once again, you can also use your calculator to check this out and you see that you have the same answer as we have here. Thank you for watching this video on division of sets. Pick more examples on division of sets and try your hands on them. If you have any problem, you can interact with me on my social media handles and I'll help you solve those questions. See you in the next video where we will tackle another very important thing in sets, rationalization of sets. Bye bye. We are on the topic sets. In the previous video, we learned how to divide a set. In this video, we are going to learn how to rationalize a set. So let's begin by learning what rationalization of sets are. In some fractional sets, the denominators are also sets. So for example, in this example, we have 1 over square root of 3, 3 over 2 square root of 11. So you can see from here that this is a fractional set, a set involving a fraction, or a fraction with a set in it. Now the denominators are also sets. Now whenever you have this, we see that the denominators are irrational. So from here, square root of 3 is irrational, 2 root 11 is irrational. So what we do is that we want to rationalize this. We want to make the denominator a rational number or a whole number. So rationalization is the process of making the denominator a whole number or a rational number. So we want to change this denominator here into a whole number or a rational number. That is the whole process or the whole idea behind rationalization. Now how do we do this? This is done by multiplying the numerator and the denominator by the denominator. Let's pick an example to illustrate this. So if you have x over square root of y, now you can see from here that the denominator, this is a fractional set, and the denominator is also a set. So you have to rationalize this. So what you do is that you multiply both the numerator and the denominator by the denominator, which is square root of x. So it's going to be x over y, which is the fractional set itself. You multiply that by, you multiply both the numerator and the denominator by the denominator. So the denominator is square root of y. So you multiply x by square root of y. You multiply y by square root of y. So you can see from here that we are going to have x times square root of y, which will give us s root y, divided by, now square root of y times square root of y will be y. So you see we have removed the square root from the denominator. That is the whole idea of rationalization. Let's pick some real examples and see how this is done. So we are being told to rationalize the following, and we have been given from question 1 up to question 5. So let's pick them one after the other. The first one, we have 2 over square root of 3. We are being told to rationalize this. So once again, whenever you are told to rationalize a set, multiply the numerator and the denominator by the denominator. The denominator here is square root of 3. So you multiply 2 by square root of 3. You multiply square root of 3 by square root of 3. Now we know this is going to give us 2 times square root of 3 all over square root of 3 times square root of 3. 2 times square root of 3 will give us 2 root 3. Square root of 3 times square root of 3 will give us 3. So you see we have now changed the denominator, which was an irrational number, to a rational number, which is 3. Let's pick the next example. We have square root of 2 over square root of 7. Once again, you multiply both the numerator and the denominator by the denominator. So you multiply square root of 2 by square root of 7. You multiply square root of 7 by square root of 7. Now this will give us square root of 2 times square root of 7 divided by square root of 7 times square root of 7. Since these are multiplying, we are going to have 2 times 7 to give us square root of 14. Then square root of 7 times square root of 7 will give us 7, as we have here. Let's pick the next example. We have square root 6 over square root of 32. Now we can see clearly from here that 32 is not in its simplest form. So what you have to do is to break it down or reduce it to its simplest form. Now we know that to reduce this, you are going to have 6 is already there. So you have 6, then divided by, if you are breaking 32 down, you are going to have square root of 16 times 2. We have done a lot of this, so you should be conversant with how to find these two numbers by now. Then this will give us is equal to 6 over square root of 16 times square root of 2. It will give us square root of 16 will give us 4. Then we have square root of 2 here, so 4 times square root of 2. Then we can see from here that 2 can cancel itself. 2 can cancel 4 2 times and cancel 6 3 times. So this will give us 3 over 2 square root of 2. Now you can see that this is our final answer after we've simplified this. But we still have a square root sign in the denominator. So what you have to do is that we rationalize this. Now in order to rationalize 3 over 2 root 2, what you do is that you multiply both the numerator, which is 3, and the denominator, which is 2 root 2, by the denominator, which is 2 root 2. Now this is what it means. So you multiply the numerator by 2 root 2, you multiply the denominator by 2 root 2. So you can see that this will give us 3 times 2 root 2 all over 2 root 2 times 2 root 2. So let's proceed. 3 times 2 root 2 will give us 6 root 2. Now 2 times 2 will give us 4. Square root of 2 times square root of 2 will give us 2. So you are going to have 6 root 2 over 4 times 2. Now we can see from here that 2 is a factor of 6. So 2 can cancel itself 1 and cancel 6 3 times. So this will give us 3 root 2 all over 2 has cancelled itself 1. So 2 times 1 to give us 4. So once again, you can try this on your calculator and see, and you realize that you are going to have the answer as we have it. So we have 6 divided by square root of 32 and the calculator is giving us 3 root 2 divided by 4 as we have here. So whenever you have this is what you do. You break it down into the simplest form. If you still have a square root sign in the denominator, you rationalize, and when you are rationalizing, you multiply both the numerator and the denominator by the denominator. Let's pick the next one. We have square root of 63 plus 1 over square root of 7. This is in its simplest form. Now this is not, so you first have to break this down before you continue. So if you are breaking square root of 63 down, you are going to have 9 times 7. So square root of 9 times 7, then plus 1 over square root of 7, which is already there. We know that this is going to give us square root of 9 times square root of 7 plus 1 over square root of 7. Then it will give us square root of 9 will give us 3 times square root of 7 will give us 3 root 7, then plus 1 over square root of 7. Now you can see everything here has now been broken to its simplest form. But we still have a fraction here, 1 over square root of 7, and the denominator is a third. So we have to rationalize this part. Now don't forget that this is not a fraction, so we will not worry ourselves with this. We are only worried with the fractional part, so we rationalize only this part. Now how is that done? We leave this part alone since it's not a fraction, so we are rationalizing here. So you multiply both the numerator and the denominator by the denominator. So we are going to have 1 times 1 over square root of 7 times square root of 7 over square root of 7. Now we are going to have 3 root 7 plus 1 times square root of 7 divided by square root of 7 times square root of 7. You know that this is going to give us 3 root 7 plus 1 times square root of 7 will give us square root of 7 divided by square root of 7 times square root of 7 will give us 7. Now you can see this is the same as 3 root 7 plus, there is 1 here in front of the square root of 7, so we are going to have 1 over square root of 7, 1 over 7 square root of 7, since we have 1 here, so 1 over 7 times square root of 7. Remember, nothing has changed here because this square root of 7 here is also over 1, so we are going to have 1 times square root of 7 over 7 times 1, which will give us 1 over 7 square root of 7. Now we have square root of 7 under this square root. We have 7 under the square root sign. We have 7 under the square root sign, so we can add the numbers in front. Don't forget that you can only add when the numbers under the square root sign are the same. So we add 3 to 1 over 7, then square root of 7. If you watch the video on addition, you will see that 3 plus 1 over 7 will give us 22 over 7, then we have square root of 7 here. So once again, you can also try this on your calculator and see, and you see that if you punch this on the calculator, you are going to have 22 over 7, then square root of 7. So take your time and go through the whole process, and you see that it is very, very simple. Let's pick the last example. We have square root of 2 plus square root of 5 all over square root of 10. Now you can see everything here is in its simplest form. You can't break square root of 10 further because it has no perfect square in it. This has no perfect square and that also has no perfect square, so they are all in the simplest form. So straight away you rationalize. When you are rationalizing, we say that you multiply both the numerator and the denominator by the denominator. The denominator here is square root of 10, so you are going to have square root of 2 plus square root of 5 divided by square root of 10 times square root of 10 divided by square root of 10. So you multiply square root of 10 with what is on the numerator here. Now remember, we have a binomial here. We have 2 terms here. So you put them in brackets, then you multiply it with the term outside the bracket. Then when you come here, we have square root of 10 times square root of 10. So square root of 10 times square root of 2 will give us square root of 20 plus square root of 10 times square root of 5 will give us square root of 50. Square root of 10 times square root of 10 will give us 10. Now, square root of 20 and square root of 50 are not in their simplest form, so you have to reduce them to the simplest form. In doing that, you have square root of 4 times 5 plus square root of 25 times 2. This will give us square root of 4 times square root of 5 plus square root of 25 times square root of 2. Square root of 4 will give us 2 times square root of 5 will give us 2 root 5, then plus square root of 25 will be 5 times square root of 2 will give us 5 root 2, all divided by 10. Now we can't add what is here because we have 5 under the square root sign and we have 2 under the square root sign. They are not the same, so we can't add. Neither can we cancel here since we can't factorize a common factor out of the numerator here. So this is going to be our final answer. You can try this on the calculator and you see that this is what you are going to have as your final answer. Thank you for watching this video on rationalization of surds. Now you realize that the questions in this video you are being told to rationalize. In most cases that does not happen. You will be given a question and when you solve the question to a certain point you will have to rationalize from there. In the next video we will consider examples that involve us solving the question then being asked to rationalize at a certain point. So in the next video we are going to take more examples on rationalization of surds. Bye bye. We are still on the topic surds and this is the last video on surds. In the previous video we learned how to rationalize a surd. In this video we are going to pick questions where we may be required to rationalize at a point in time as we solve the question. So let's look at some examples. So we are being told to evaluate the following. We have been given the first and the second question, so we pick them one after the other and solve. So the first question that we are rationalizing is, we are supposed to solve is 14 plus 3 root 7 in one bracket, then 2 minus 3 over root 7 in another bracket, and we can see from here that they are multiplying. So as you have been doing, you use the distributive rule here. You distribute what is in the first bracket over what is in the second bracket. So from here we pick the first term in the first bracket, which is 14, and multiply it with everything in the second bracket, which is 2 minus 3 over root 7. We pick the second term in the first bracket, which is 3 root 7, and multiply it with everything in the second bracket, which is 2 minus 3 over root 7. So from here we do the expansion. We are going to have 14 times 2 in one bracket, then plus 14 times negative 3 over root 7 in the other bracket. We move on to this side. We have 3 root 7 times 2 in one bracket, then plus 3 root 7 times negative 3 over square root of 7 in the other bracket. So from here we deal with what is in the bracket. We know that 14 times 2 will give us 28. 14 times negative 3 over root 7, we know that 14 will multiply 3 to give us 42. So you divide that by root 7. You divide that by root 7. Since 14 here is 14 over 1, so 1 times root 7 will give us root 7. There's the negative here, so we have the negative. Then we come to this side. 3 root 7 times 2 from the properties of surds. We have seen that 3 root 7 times 2 is the same as 3 times 2 root 7. 3 times 2 will give us 6, so 6 root 7. Then when you come here, we have 3 root 7 times negative 3 over root 7. So from here, 3 will multiply 3 to give us 9 as we have here. So we have 9 root 7. This one, all of them divided by root 7. Since this part here, which is 3 root 7, is divided by 1, so 1 times square root of 7 will give us square root of 7. Remember, there's a negative here, so the negative comes outside here. So from here, we continue with the simplification. We know that from what we've learned from the division of surds, 9 root 7 over root 7 is the same as 9 times square root of 7 over 7. So we are going to have 28 minus 42 over root 7 plus 6 root 7 minus 9 times square root of 7 over 7. So we have square root of 7 divided by square root of 7 giving us square root of 7 over 7. So we continue with the simplification. We know that this is going to give us square root of 7 over 7 will give us square root of 1. Square root of 1 is the same as 1. So negative 9 times 1 will give us minus 9. So what you do is that you group the numbers, then you group the sets at one side too. So we have 28, then minus 9. Since this whole thing will give us minus 9, so 28 minus 9, we have minus 42 over 7 plus 6 root 7. So if you simplify this, you are going to have 28 minus 9 give us 19. So minus 42 over root 7 plus 6 root 7. Now we can see from here that we have this here with this denominator being a surd. So what we have to do is that we have to rationalize this part. We can't present this as our final answer. So we have to rationalize this part. Remember, we are not rationalizing 19 or 6 root 7 because they are not fractions. We only rationalize fractional sets which have the denominator as a surd. So from here, what we do is that we rearrange it. I'm going to rearrange such that this one becomes the last step. So I'm going to have 19 plus 6 root 7 minus 42 over square root of 2. So in rationalizing this, we know that we are going to multiply both the numerator and the denominator by the denominator. Remember that we are rationalizing this part, so we are not, the multiplication won't affect this. It's only the part that we are rationalizing. So we are going to have 19 plus 6 root 7 minus 42 over root 7 times square root of 7 times square root of 7. You know that this is going to give us 19 plus 6 root 7, which is already there, then minus 42 times root 7 will give us 42 root 7. Root 7 times root 7 will give us 7. From the properties of sets, you know that. So we cancel some terms out. We know that 7 can cancel itself 1, or we know that 42 root 7 over 7 is the same as 42 over 7 root 7. So from here, we know that 7 can cancel 42, 7 will cancel itself 1 and cancel 42 6 times. So if that happens, you are going to have 6 over 1 root 7. 6 over 1 is the same as 6, so you are going to have 6 root 7. Now we can see clearly from here that we have plus 6 root 7 here, we have minus 6 root 7, so they can cancel each other out. So from here, plus 6 root 7 will cancel minus 6 root 7. So that this side will all be gone, this side will be gone. So we now have 19, since this side will be 0. So you can see from here that when you get to this point, all that you need to do is to rationalize the fractional set and then simplify. So after the simplification, we realize that we now have 19. So you can try the question on your calculator and see, and you will see that your final answer will be given to you as 19. Let's pick the next question. We have 2 over 3 plus 2 root 2 plus 1 over 3 minus 2 root 2. So we can see this is a fractional set, this is also a fractional set. Now there are two ways of doing this. You can choose to rationalize this part, then rationalize this part. After that, you add what you get. That is quite long, so we are going to choose the easier way now. We are going to find the LCM of the denominators here, then we solve it as if we are solving normal fractions. So from algebra, we said that when we are given fractions like this to solve, you can get the denominator, the LCM of the denominators, by multiplying the denominators. So here we are going to, the LCM we are going to use is this term here, 3 plus 2 root 2 times 3 minus 2 root 2. So we multiply the two denominators and we use it as the LCM, as we can see here. So we have found the LCM to be 3 plus 2 root 2 in one bracket, then 3 minus 2 root 2 in the other bracket. So let's continue with the simplification. So we take this denominator here, then we divide it by the LCM. Remember, if you divide this denominator here by the LCM, 3 plus 2 root 2 is going to cancel 3 plus 2 root 2. So you are going to be left with 3 minus 2 root 2. So what you get, you multiply to the numerator. So you multiply 2, which is the numerator, by the remainder after we've divided, which is 3 minus 2 root 2. then our addition sign comes here. Now when you come here, the denominator is 3 minus 2 root 2. You divide that by the LCM, which is 3 plus 2 root 2, 3 minus 2 root 2, and you're going to be left with 3 plus 2 root 2. You multiply that result by the numerator, which is 1. So 1 times 3 plus 2 root 2. Remember, we put 3 minus 2 root 2 and 3 plus 2 root 2 here in brackets because they are binomials, and you have just one term multiplying a binomial. So you have to put the binomial in a bracket, then you put the other term outside the bracket. That's why when you come here, we have 2 times 3 minus 2 root 2, then 1 plus 1 times 3 plus 2 root 2. So from here, it is a normal simplification that we have been doing. You know, to simplify this, you use the distributive rule. So 2 will multiply 3 to give us 6. 2 times minus 2 root 2 give us minus 4 root 2. Then we come here, 1 times 3 will give us 3. 1 times 2 root 2 give us plus 2 root 2. Then we do the same thing for this side. You can see the denominator here is also a binomial. So we distribute what is in the first bracket over what is in the second bracket. So 3, which is the first term here, will multiply everything in the second bracket, which is 3 minus 2 root 2. Then plus 2, which is the second term here, will multiply everything in the second bracket, which is 2 root 2 into bracket 3 minus 2 root 2. So we proceed. We know that when we come here, we are going to have 6 plus 3. So we are grouping the numbers and the sets. So 6 plus 3 will come to one side. Then 2 root 2 minus 4 root 2 plus 2 root 2 will also go to the other side. Then when you come here, we do the expansion. 3 times 3 will give us 9. 3 times minus 2 root 2 give us minus 6 root 2. 2 root 2 times 3 will give us 6 root 2. 2 root 2 times minus 2 root 2 will give us minus 4 times 2. Now this is what is happening. 2 will multiply 2. 2 will multiply 2 to give us 4. Root 2 will multiply root 2 to give us 2. So we have 4 times 2. But don't forget that there's a negative sign here, so the negative must come. So we continue with the simplification. 6 plus 3 will give us 9. If you come here, we have minus 4 root 2 plus 2 root 2. The numbers under the square root signs are the same, so we can add. So we add negative 4 to 2, and we are getting negative 2. So you have negative 2 root 2. Now when we come here, we can see that we have minus 6 root 2, then plus 6 root 2. So minus 6 root 2 will cancel plus 6 root 2. So you are going to have 9, then minus 4 times 2 give us 8. So 9 minus 8. Since minus 6 root 2 and plus 6 root 2 has cancelled each other out. So minus 9 minus 8 will give us 1. So this whole expression is going to be 9 minus 2 root 2 all over 1, which will give us 9 minus 2 root 2. Once again, you can also check this on your calculator and see if you get the answer that we have here. So you can try it on the calculator. So let's try this and see. We have 2 divided by 3 plus 2 root 2. Then we press this sign so that the cursor will come here. So plus, we have 1 over 3 plus 3 minus 2 root 2. Then you press equal. So the calculator is giving us 9 minus 2 root 2, just as we have here. So once again, after you solve the question, you can try to check calculator and see if your answer is correct. If it's wrong, check through the process and see where you got it wrong. We did a lot of multiplication of algebraic expression here. If you are not clear on any of them, I recommend that you watch the video on multiplication of sets and you get it. So in this video, we did a lot of multiplication of sets. So if you watch the video on multiplication of sets, you are going to get it very, very well. Thank you so much for watching this video and all the video on sets. This is the end of the video on sets.